Go.
So we're now on the back to the larger copper arm ring. That was the six wires with a central seventh core wire, and with the hothead special torch with the Map Pro, we did this end, fused that, worked out really well, but it took about 5 minutes. And so now I'm going to show going to the oxyacetylene, which again we were using the oxyacetylene on that little tiny finger ring here, this little 2x2, but with a micro torch. Now I'm to the big main standard torch, and we're going to show that when you have a larger area of a heat sink on your piece, the more intense, hotter flame can work faster. But because it can work faster, it can also, because of that extreme additional heat, it can also damage or fuse too much or get too much of a melt. So we have to be very careful in that regard. So we're balancing less time with more potential concern of the fusing being bad. Starting this up. So there we go, and then that goes out. This is also an old torch head from my oxyacetylene that I really should buy a new one, but why would I? The only real problem is that the finite adjustment on the oxygen seems like it changes. So anyway, there we go. Slightly neutral flame. And I just touched the button, so it changed. That's kind of what I'm talking about. There we go. Clean off that end, and now we're going to fuse it. So basically the same exact process as the other one. Same fixture setup, same angle on that inclined fire brick. It's just, it's got to get hot a lot faster. And definitely. So it's already starting to go. So just like the other one, I want to rotate it. I over-rotated it. There it is. There it goes. That should be it. And we'll get a little bit more. So now I'm getting a smaller area fused at any given time because I'm being really careful where I'm applying heat. So it's not fused all the way around, but in varying degrees of fused in towards the center. There we go. A little more here. There we go. That's, all right, I think that's about all I need to do. So you can see how much faster that went. It's also a little bright for my safety glasses too. If I was doing that a lot, I'd have to go to some other kind of glasses. Yeah. So I want to show. Check this area out. See how the fuse goes up about 5/16 or so, maybe even 3/8 up into here. But when I roll it over, see how it's about half of that? And that's because I'm being real careful not to over melt any of that area. So we'll do a little bit more, just even that out. So I haven't cleaned it at all, right? I'm just going right back, and it should continue to fuse without a problem, even though I haven't cleaned it. Talking about that whole heat burns off the tarnish and then keeps the oxygen away from the. See that? A little bit more there. Look at that. You see that? Hope that.
Yeah.
There. Okay, and now it got so hot it drooled a little bit, which is fine. I'll show you the drool here in a minute. But that's all the fusing we got to do. I can show you the. See the drool? So that got so hot across that entire diameter that it now started to drop gravity. There's so much mass and so much heat in there, it overtakes the surface tension and then drops via gravity. It was sitting like this. See that little white spot on
Yeah,
there?
it actually took some of the brick.
Yep. Okay.
Cool.
Ooh, got lucky. Okay.